Yet another normal forms example. Here's a set of tables that a graduate student brought to me once that was having problems sorting through and pulling information out of the volume of data they had. They were used to working in R, or actually I think in this case Systat or SPSS, one of the statistical packages. And their idea or normal way of looking at the data in a statistical package is to have this flat file structure. In this case, they were collecting data at a site. And at that site, then, they had a bunch of information associated with the measurements they made. So they would GPS the UTM coordinates, and they would identify the vegetation and make some vegetation measurements. Now, some of it was a classification, and then there were individual measurements they would make at the plot. And then there were soil measurements they would make, identifying the soil type and then making soil measurements. And then they would make biometric measurements like litter or a bunch of other things. It was actually quite a bit bigger table than this. I've subset it. And then they would sample for the worm species, sometimes at multiple times per plot, sometimes at a single time per plot. But here I'm just assuming that they're only doing one measurement per plot, and they're grouping that so that they have basically a measurement of the worm species. We'll call them A, B, C, D, E here, and then the number. And in some cases, they would get all 5. In some cases, they would get 1, or they get various subsets. So you can see here that I have the site, the GPS measurement, the vegetation association and its type, the soil association and its type, and then a litter measurement. And then the worms measurements they had. So they had worms A, B, and C here, B and C here, C and B here, A and B. And of course, this is a flat file structure, and so we want to go to normal forms. And remember, what's the first thing we do? Identify the repeat columns, and we put those into redundant rows. And so it's the worm species that we have here in number, worm species and number, up to these 5 different kinds we can have. And so, again, we remove the duplicate columns to create first normal forms. And so for each of the observations of the types of worms, we're going to put the data in here, and copying the data that isn't associated with the worms. And so no repeat columns. Well, so here we have then this no repeat columns in first normal form. And remember, there's the site 1, 2, 3 now, 1 for each of the worms. I'm copying the easting and northing information for the GPS and the Veg-code and the veg type and the soil type description and the litter. But now I have the worm species and number split, right? So again, this columns for rows things to get rid of those redundant columns. And then I have to decide, well, okay, what are my functional dependencies here? What do I need to identify the types? And, so we have basically sites and worms, and then we have stuff associated with the sites and stuff associated with the sort of the worms. So I kind of have to split that up into my table. Well, we basically have all the site information, and then we have the site species count, right? So there's the site and the species, and that's kind of really the crux of the table, the site species count. That's that one concatenated key, the site species, and then the stuff that's dependent on that, the count. And so there's that, again, what I would call the linking table, and then the site table. And so I have all the site information, and then the site species information, the count for that site species comparison. It kind of harkens back, if you look to the Flonks, the invoice order example that I also have for this section of topics on normal form examples. So look at that, look at the similarities. This step, we're saying, oh, there's this one column, or one, I should say, table that has the 2 columns that really are the key for the main table, and that gets pulled out. And then I have another table with the stuff that's function dependent on it. So here, these set of functional dependencies and this set of functional dependencies really is all the functional dependencies in the table, the original table. So here then I have some transitive functional dependencies to get rid of. In this case, if I know the veg code, I know the vegetation. If I know the soil type, I know the soil description. Now, there were actually a bunch of other things associated with the vegetation, associated locations, landforms, all sorts of other things, but they were all dependent on the veg code. And the same thing for the soil here. I had the soil type. There were a bunch of soil properties that were associated with that soil type. So basically, I have to pull out a veg table and a soil table, because those are my functional dependencies, right? If I know site, I know easting, northing, veg code, vegetation, soil, description, and litter. So I make a second table of these 8 items here, and that to split the functional dependencies out of that, I'm going to go to third normal form, right? So there's the veg and soil, those transitive functional dependencies, and then there's the site code, which will just have the veg code and the soil code, and the litter, because that's associated with the site, one measurement of litter at the site. And this third normal form that gets split out, where I have this site code table, I have the soil table and the vegetation table, right? So here's the site with the litter that's function dependent, that one litter measurement. I have the soil and the vegetation code. And then that vegetation code is associated with another set, in this case, the vegetation name, and the soil with another set of data, the soil name. And so basically I have these in third normal form now. And thinking about this, you might have been able to, once you've got this concept of normal form, be able to identify this really from the base table itself and the relationships. Now again, I wrote out the table and then split it using the rules. But if you were to come at this in the data collection step before you did the data collection, you would think about each of the variables you're going to collect and could really set these tables up before collecting any data. Right? Because you know that, well, I'm going to have a site and a set of measurements associated with the site, and there's the veg code and the soil code. Now, the litter is going to be dependent on the measurements I make on the site, and so is the veg code. But once I know the veg code, there's a bunch of other vegetation information associated with that veg code and soil information associated with that soil code. And then I have, really, in my collection, the site worm are my main things. And I have the site, then I know all the site information. There's the worm species and number associated with that site information collection. And then there's the veg and soil data that I'm also measuring at the site. So you could pretty easily identify these pieces in advance. And that's the notion of when you work with normal forms a lot, you get an idea of, well, okay, what are the tables that I'm going to need? Of course, then with each of those tables, you'd still want to take a look. Are there any transitive functional dependencies? Can I split this table up further? Because sometimes you let one sneak in. Anyway, another example of going from a flat file to normal forms.